Well, thank you for the invite. I'm going to change it up a bit now, so I've gone purple for a start. Sorry, I had to get our branding on. And I'm going to come down in scale quite dramatically and be problem focused. So start with some very sort of challenges from the practice point of view. So it's quite different. It does overlap with lots of the points that we've talked about, but again, I'm taking quite a different perspective. So I just need to acknowledge as well, this isn't just me, it's with two of my postgrads here, Pammy Sine and Rebecca Smith as well. So I'm going to take it for read, all the issues about water security. We've heard a lot of those today, so I thought by this time of the day, we didn't need me to go into those. What I would like to just point out, though, is that in terms of security and sustainability for me, it's much more an integration of these concerns socially, economically and environmentally. And it's right, I did start off my academic career, I suppose, as a physical scientist, but as I've gone on and got more into water governance and practice, I'd really sell myself as an interdisciplinary, sort of transdisciplinary researcher, really, with a huge engagement with stakeholders. So if we're going to meet these challenges, and that's one of the recentish maps around baseline water stress, I think there's a number of challenges thinking about the water supply chain. One of this is understanding the competing uses of water. So that does mean supply, treatment, use, but it means a lot of different uses. Yes, irrigation, yes, agriculture, but also business, manufacturing. So thinking about kind of who is the user, where they are in this system. So coming down to some of these problems and challenges from a different perspective, rather than necessarily just doing this important, but relatively straightforward global mapping. If we're going to go to application and operationalisation, we need to think about the people in this. And that means consumers, that also means business, it means the practitioners and the managers too. Embracing that water is a flux, and we've heard a bit about that today already. So thinking that it's not partitioned into separate silos, it's a flux, it moves around our landscape, so we do need to think about these multiple uses and make decisions accordingly. So we do think about it, water being used in energy and agriculture. But let's embrace that and think about it differently, because I think I'm going to say by the end of this talk, there's some win-wins by doing this. And the third challenge really is then thinking about how do we integrate across very different perspectives, and how do we make those rules? How do we operationalise the governance? Who has a voice? Who has the power to make this accessible and equitable for people? We've heard a lot about the resources there. We've never heard about the power yet, about who drills that borehole into groundwater supply and who controls it and who controls the access to it. And that's a really important issue. We might have supply, but how do we get to it? So I think we need to tackle these if we're going to have any chance of meeting sustainable development goals. And for me, that means doing transdisciplinary research. So what I'm going to do today is talk about two case studies. And it's often as you sit at the outset of a day presentation, you think, oh, where's my work going to sit? Luckily, I've got one on India and interbasin water transfer. So for me, this is quite big scale, but compared with what we've heard about global modelling, it's probably relatively small. And the second one is then coming sort of back to the UK and thinking about our multiple uses of water. So I'm going to present some work that's in the northeast of the UK, where there's a really large mining heritage. So we're dealing with pollution problems in mine water, but we've also got all the problems about use and the trade-offs with them. So we're going to start with interbasin water transfer in India. So this is a massive plan for India to then hopefully produce equitable and fair supply of water across the country, with the very basic premise being moving water from areas of excess supply to then areas of deficit. So it sounds quite grand and straightforward, but one of the latest projects they're looking at is this interlinking project, and they're talking about 60-odd engineering designs that both are within states but between states. So again, thinking about the governance and the decision-making process is really problematic. And again, who's got the power? Who's got the voice to say who wins and loses in this? So we've been doing a bit of research that just looks at two of these links that supposedly then work together. Now, our approach has been that we want to understand both the supply, so understand the hydrometeorological supply of water and in the rivers as well, so what gets from rainfall to discharge, but also thinking about the demand. And we've been in this messy area where, as a lot of the presentations have been today, where we're looking at imperfect data. And then we've put that imperfect data to try and get this social hydrological understanding and then use this WEAP model that can then actually model these transfers. So we haven't developed any new models, but we're using these existing models. So our study area, it's here in almost central India, and the two links that we've got are then in this top diagram, and we've colour-coded these basins. So the red, orangey, yellow ones are ones that are then classed as donor basins, where somebody somewhere has decided they've got surplus water to transfer, and the green ones are then colour-coded as the recipients. And the idea is these two purple links will then operate together across, with some engineering solutions, but also across natural rivers to then transfer some of this flow. And the big premise in all of this is then that there's excess water in that very sort of yellow basin in the top left, and much more of the demand is down here in the green basin. So if we start looking at the very large scale, and again, even this is problematic, getting data at this level, thinking about, again, we've kept the colours now for the 6 basins, so the top ones are then the donors, the bottom line are then the recipients, but thinking about what have we got in terms of discharge in our rivers as a supply. Here we've got the very annual data, and this is the data that has been used to develop the plans. So it's very coarse data. There's not many points where you've got discharge data, so often you're taking one point as being kind of the truth and the real assumption of what's happening about flow in basins that are hundreds of kilometres in area. But we've got a similar interannual pattern there. You might argue, some analysis, you might see El Nino impacts in that, but it's pretty similar, although obviously the magnitude of discharge in rivers does change. We can then start to look at it on a much more monthly timescale, and this then hasn't been done in any of the plans that have been made for this interbasin water transfer. So we can start to see what we've done is we've got these lines here sort of about the average, and we've got the excess and below the average, and we can start to see clear demarcation then about the monsoon and non-monsoon season. So again, if we want to supply water, shouldn't this be factored into operationalising how we're going to do it? Do we operationalise this so there's 1% of water taken off all year? This data would start to argue we shouldn't. But again, there's a similar pattern across all the basins. What we've then managed to do with the WEAP model is take 2 basins. I'm just going to illustrate this with 2 basins. It gets very complicated then showing what graphs and what basins we want to look at. But start to take one donor and one recipient basin. So they're up there on the top line here. And then these bottom graphs is then, we're running it through WEAP, and yes, there's lots of assumptions, but we have tried to model the consumption in terms of consumer behaviour, thinking about irrigation, thinking about agriculture, thinking about manufacturing, thinking about urban areas. So we've got a bit of a guesstimate when you put all these together. But even by that, you can start to see that the darker colour here is pre-link, the lighter colour is post-link. And then we've got the donor and the recipient basin next to each other. So it doesn't look too bad. You can see that hopefully there's excess water in the donor basins, and it makes a slight difference then to the recipient basins. So it doesn't look quite so bad, but again, what's the investment in this huge engineering scheme to produce not a lot of change in some of these basins? And what becomes interesting is then, when you think under what pumping regime, what transfer regime are they going to operate? And this isn't very clearly specified in any of the plans. So it's very much we'll operate at the same level throughout the year. There's not really any information about how do you say when we should pump, when should we stop transfers, what situations, how should it work. And what we've got here in the dotted line, we've got kind of the level that's proposed for the water transfer. And then again, we've got for the donor and the recipient basins, the pattern then may be of supply in both monsoon and non-monsoon. So you can suddenly start to see that any of these assumptions that they're using might be okay for the monsoon season, they're not all right for non-monsoon. And again, we haven't gone into this, but what are the implications of this for people and the social justice elements of access to water? Who wins in this access? Some of the big manufacturing might win that was in the green basin on the bottom right in that initial study site, and you might have some really core losers from some of these donor basins. So thinking about this as a very applied problem, and that's a very quick summary, obviously, of almost a whole PhD that's trying to work that out. But we have got some of these big engineering schemes that are set up there to be brilliant solutions for some of the water scarcity, sustainability issues. But if you undertake a socio-hydrological analysis, and we'd argue that there aren't many that take both the understanding the hydromet and then consumption and demand, that on average, we might be looking at transferring about 16% of available water, per annum in one of the that very initial donor catchment. So it doesn't sound much, so we've got to think about the investment. But the transfer isn't then sustainable all year round, and that's before we even factor in things like climate change and water availability and how demand might change. And again, who makes some of these choices? We've heard a lot about the market, but where's regulation in this as well? I mean, we've heard a bit about that from Australia, but so what's the governance and the rules there in some of this? But also, one of my challenges was understanding water as a flux. So how do we think about the impacts of this? Be that in terms of physical impacts, in the rivers, in the biodiversity, but also in terms of people's access to water. And a lot of this thinks about the very large, maybe government institutional schemes, but what about lots of the distributed, maybe energy supply, water supply that starts to go on in lots of these rural areas? And so a lot of that isn't factored into any of these big studies and the way they're then proposed and get permission. And what's happened then in India as well, and partly the drive for this research, is it's been very, it's not been very transparent at all. So there's a lot of fear in a lot of these basins about who's going to have access to water and who's going to have supply. So I'm now going to flip and think about multiple waters in the UK, and I'm going to bring this down even smaller scale now and talk about a basin that's all of tens of kilometres squared. And I think for a lot of my life, I've really worked then on surface water. So I hang my head in shame with all the hydrogeologists in the room. And a lot of the surface water management we do in the UK doesn't often think about the implications for groundwater. And so we've got a project that we've got partners with the Environment Agency, Northumbrian Water and the Weir Rivers Trust, trying to understand kind of what integrated resource management might look like, or what it should look like, to think about what we're doing with the surface waters and how that interacts with the groundwaters. And again, one of the arguments I want to make is then thinking that if we want to understand the causality and consequence, so what we do with our water, maybe the use, maybe even flood events, the management, that we need to think about this whole water supply chain. And at the moment, I don't think we do that routinely in the UK. Any of the stakeholders can argue that with me later. So the whole bit about this research, I said I'm starting with very much an applied problem, was taking a map like this from Northumbrian Water. And they have a massive issue that this yellow dot in the middle here is a Stonygate borehole, which they're using for pumping drinking water supply. Now they're having to blend the water that comes out of this borehole because it's too high in nitrates. So they're paying to take the money out of the ground, making money off then supplying it to customers, but they're having to incur an increased cost in blending it with other water. Now, their concern is that this fault A is then a source area of pollution, and their assumption is that that pollution is coming from the surface waters moving through a series of faults and then getting into the borehole. So the question was, is this really happening? Can we find out why? So we focused our research then on trying to understand a relatively small tributary that's there in blue at the top end of Lumley Park Burn. So this is then the Herrington Burn, which flows through ex-mining area. There's lots of topsoil around. There's lots of mining waste that's then been built on and developed with some of these mining villages. So it looked quite simple to start with. It's failing in terms of WFD, the water framework, so it's failing in terms of being messed around with too many kind of concrete structures. It's failing in terms of biodiversity and fish, but it's in quite a deprived area of the UK. So if you walk out there, you'll find shopping trolleys in the river. It's a general dumping ground, and it's a complete mess. Hence why they think it's a source of pollution in the drinking water. So what we then started to do is Northumbrian Water and the Environment Agency have undertaken a whole mapping exercise of this purple area, because this is then the limestone aquifer. It's got a series of nitrate vulnerable zones on it to protect it from pollution, and because that's the main source of drinking water in a lot of the northeast. That mapping stops at that purple area because that's not then the limestone aquifer. So our stream, as you can see, is just off that. So again, there's a distinct, this is quite interesting in terms of integration of our resources, in terms of who knows what, where do bits of work start and stop. What the EA have done, their groundwater specialists, is for the magnesium limestone area, they've done a series of risk maps. They've produced some risk maps in conjunction with BGS that's based on then drift thickness. So we've done our own version for this. So the red area is where the drift in the region is then 5 metres or less. So they think the potential for surface water to connect with groundwater is incredibly high. So again, these are areas we need to be careful about. So our stream in question sits nicely on that red area. We can also then interrogate borehole data from BGS to understand kind of what's the soil doing in this as well. I think, again, we haven't heard much about the capacity of the soil to change kind of the movement of water through our systems. And we can see that we've got some clay lenses, and we then have to have an understanding of whether they do protect the groundwater, do they limit it, what's happening to our sources. And then what we can do is I've just put the fault lines on top of this map again, and we can see that this line here is then our fault A, so it does sit right at the headwaters of that stream. Now the assumption is the surface water is crossing that fault, getting down it. When you look at then the latest maps of where that river network is, it doesn't even actually cross that fault. So are there some assumptions here that are really wrong? If you walk out though and you do walkovers, you can start to see that there's effectively an old, unused, dry river channel that's partly been blocked up in places as well. So it led us to think, what's happened in terms of development terms to this area as they've done building, as they've thought about mine spoil and tried to reclaim some of it. And if we go back to the first series edition of OS maps, we can see that the stream channel is this green line. So once upon a time, it might well have done. And if that stream still had that course, then it could possibly make that connection. But it's not there anymore. So what's happened to it? We can interrogate more and more of the OS maps, and we can see that the length of the stream gets shorter with each edition. And we can see as well at the bottom end they start doing some messing around with it as well through some of the spoil heaps. So there's quite a big change then in what's happening. And interestingly, it was then trying to understand why. And if we go back to topography and we start mapping the area in terms of likely flow paths and source areas, we can see that we've got this yellow catchment where you think you'd be supplying surface water, but we're not. So we then beg the question, where's this water? If you're out then doing a walkover, you can stand there, you can't see anything, you can't work out where it's going, but you can then hear subsurface flow. And our only assumption at the moment is that is then in some sewer network or runoff network that has then, in terms of developing the area, they've put slightly subsurface, not very much, and you can hear it. At the moment, we're in a very interesting position where we're trying to work out who's got a map of this network, where does it go, where does it kind of come in? Because it doesn't necessarily come into the stream. We've done walkovers and we can think about additions and losses to that stream. Interestingly, we're working with Northumbrian Water, and we've got close relationships with both Durham Council and Sunderland Council. No one knows where these plans are and who's done what. And so considering we're partly led through a problem that's set up by Northumbrian Water, and then we're saying actually it could be your very own sewers, if they're not being managed or haven't been built correctly, could be putting that water straight down your fault line. It's quite interesting. So we also have a whole series of walkovers taking water chemistry and trying to understand the stream, but that's pretty straightforward compared to this story. So it's a very local story, but I think from a lot of the research I've done across the region and other areas around the UK, it's not uncommon. And this coordination then between development, infrastructure, water supply, water treatment, flood management, water framework directive, it is very siloed. It's not very joined up, and this is not uncommon. As part of this study as well, we're looking at another VEC that's partly ephemeral, where we actually do have sewage treatment, treated water being pumped out into this river. But again, it assumes that it's got water in this river, and that will dilute it, so then the final water is at the required standard. But if the stream's ephemeral, all that assumption is incorrect. And again, there's lots of illustrations of that where we can find it in the UK. So I think we're in a situation where lots of these multiple impacts on water resources are not always recorded. So we're not capturing these multiple uses and how they're factored then into the supply chain of water. And particularly thinking about this integration of surface water, water infrastructure and groundwater. And I haven't even mentioned some of the mining and what we're doing with our wastewater from mining in the UK as well. And that, of course, plays around with the groundwater levels, it plays around with the stream water quality, but also provides a really interesting opportunity for capturing, say, some of the heat from the wastewater as well. Organisations possibly need to work together across the supply chain. It's happening in the UK. We have some very good moments of connection, I'd say, more possibly around water framework directive and quality, but actually even freeing up data and sharing is often quite difficult because you've got IP in this, but also market value. But lots of this, if we don't do it, I feel is pretty detrimental in terms of in-stream water quality, costs of water supply, biodiversity, and the complexity of management. And there are, I think, some big wins if we can align the working assumptions and the premise and the purpose of lots of these different agencies in terms of managing water. So, what do we do in terms of drawing these two examples together? So I've got one in India, much larger scale than very local. But I think there's many more examples I could have talked about, but I chose these two because they're great examples about how we're not actually integrating our management. And if we don't integrate our management, I think we don't think about these detrimental impacts on people and the environment. And I think we've got to have some understanding of that as we're thinking about water security. I think we do need to think about this water supply chain and think about these multiple uses. Because I think that's going to lead us to some big wins, and rather than assuming water's waste, where it is also used in the system. And that could be, for the developed world, thinking about dual supply to houses to use the grey water better. I say develop because I think that's where we have the potential. I think we need some systemic integrated approaches for managing the whole supply chain. And this is across perspectives, organisations, managers, thinking about different purposes. Again, thinking about who wins, who loses, who's got a voice in this argument. There's a lot of work labelled in developed countries at the consumer, and they're a very small piece of the jigsaw. What are we doing about business? What are we doing about regulation? There's a whole minefield there. I think as well that there's opportunities in terms of regional development and planning where actually, if we think about the water supply chain, it's a very novel and interesting and actually just logical way to think about our resources and development. At the moment, it's nowhere. It's sort of an afterthought and potluck whether the key agencies can pull it off in a way. And I think if we don't do this, well, I think it'll be much easier to think about our sustainable development goals if we do try and brace this water supply chain differently. And I think at the moment, we're just not even making a start. Thank you.
Well, thanks a lot, Louise. Thanks for zooming back to Earth in a way and stressing again the issues of integration and coordination, where we had a bit of a glimpse in the whole afternoon, but bringing it back to our attention, also mentioning that India is not really that much worse compared to the UK. We also have lots of these coordination and integration issues obviously here. So really thanks a lot. I suggest we have one or two questions and probably then just move to the reception. I see the gentleman here is really eager to talk, so the floor is yours.
Sure.
Andrew Ross from Global Garden. DEFRA has developed the catchment area model, particularly in response to flooding. And the budget that's being applied to flooding is now 2.5 billion and going up quite rapidly. And Cumbria alone showed that the insurance value of the assets at risk was in excess of £6 billion worth of damage. So the massive financial impact of flooding is bringing about political integration and pressure on local authorities to develop a solution for catchment area. Now Northumberland and United Utilities and South West Water with their upstream thinking project are all involved in this arena, and they need access to the finance to bring this together. Is your model including any financial insurance industry valuations of these assets?
I've gone for a very practical approach today to show you what the problems are on the ground rather than thinking about solutions. So on top of this, there's a very complex web, again, about the social, political, the economic. My question to the government would be, and I have poised this at all parliamentary briefings that I've then shared, is that, again, our approach to flooding, we assume that we should protect people from flooding. We haven't really even scratched the surface of flood resilience, so how we live with it. So I think, personally, I would say, are we challenging in the right way before we even decide what the budget is? The budget that's being kind of, I suppose, rolled out is very much on championing natural flood management. Now, natural flood management is brilliant. I should say I've got a whole other bit of my work on flooding, which I haven't presented. Again, we don't know how to scale that up effectively. To scale it up effectively means that we need integration with water utilities, with planning, with development. That's not there in the thinking. At the moment, I think the county councils are kind of having to roll stuff out. I think there's some brilliant, I think DEFRA and the Environment Agency are doing a really good job in very difficult times. If you talk about water, if you talk about insurance, I do a lot of work with the reinsurance industry because I head an institute of hazard risk and resilience. We've got water re. Is that fit for purpose? Now, we're all going to be, flood re, we're all going to be charged effectively £10 a head in the UK that will then fund this. So we're saying that yes, the market should pay, but the reinsurance market is very cross that you're going to have a public funded institute that isn't actually fit for purpose. So how does that actually play out in the market? Because it's not free market. The rest of the insurance and reinsurance is free market. That works pretty well. But it doesn't work for flooding. And they're cross then because they're supported by the government, whereas the government has to do something because of public opinion. So the whole thing's a bit of a mess. I think we haven't broken it down to kind of causation and consequence at the moment.
Well, thanks a lot.
Thanks.
One more here.
Thank you. Ian Barker. I think what Louise has identified is what happens when you let organisations and institutions evolve organically, to then try and get them to undertake a different role without considering the governance and institutional arrangements and financial arrangements to actually do the job. And I think what we're seeing is organisations doing the best possible job they can do with the arrangements and the finances they have. But if you take a step back and look across the catchments of England and total up all the money which is spent in managing water, so that's money spent by the Environment Agency, by water companies, money spent on flood premiums, money spent on managing land for aquatic biodiversity and for water protection, and lots of other money as well, that total pot is about £13 billion a year, but it's all spent in silos. And because it's spent in silos, you're then not generating the potential efficiencies and synergies which you need to manage catchments efficiently. And what you're also not getting is a forum or a mechanism or the governance arrangements for people to get together and to have a conversation about how you optimise the use of that money. I'll pause there because otherwise we'll be here all night. But I think it's a really good point to end on, so thank you, Louise.
Thank you. I totally agree with you.